Okay, question number 16 is the power supply in an electric circuit is a battery of electromotive force 12 volt. State two ways in which the EMF of the battery differs from that of an alternating current power supply. State two ways in which the EMF of a battery differs from that of an alternating current power supply. So the two ways are first way, the polarity. Polarity is basically plus minus of EMF of a battery is constant, unlike an AC. Second difference is the EMF of a battery is constant while of AC generator fluctuates. Now the next question is अच्छा जो डिफरेंस है ना ए पार्ट में वो ये है कि जो डीसी बैटरी होती है उसके करंट का वन वे फ्लो होता है और जो एसी होता है उसके करंट का होता है टू वे फ्लो। ये हमने पहला डिफरेंस लिखा है। जैसे हमने जो लिखा है ना कि प्लस माइनस या पोलैरिटी कांस्टेंट होती है, इसका मतलब है वन वे फ्लो ऑफ करंट। जबकि दूसरा डिफरेंस ये है कि जो डीसी बैटरी है उसके वोल्ट कांस्टेंट होते हैं, जबकि जो आपका होता है जनरेटर उसके जो वोल्ट्स होते हैं वो फ्लक्चुएट करते हैं। तो ईएमएफ फ्लक्चुएट करता है। अच्छा, अब आते हैं जी क्वेश्चन के बी पार्ट पे। बी पार्ट है जी, द सर्किट इंक्लूड्स थ्री resistors and two open switches S1 and S2. Figure 9.1 shows the circuit. YZ is a straight horizontal section of the connecting wire that lies between two magnets. S1 is now closed. Calculate the current in YZ. They are asking that you have to calculate current in YZ, and what is the switch state of switches? Only S1 is closed. Where is S1? Okay, if S1 is closed and S2 is open, then obviously, then obvious. अच्छा जी, कैलकुलेट द करंट इन वाई जी। अब जो S2 है अगर वो ओपन है और S1 क्लोज है तो ये तो एग्जिस्ट नहीं करता। सर्किट में अब दो रेजिस्टर्स रह गए, 20 ओम और 28 ओम, और ये दोनों हैं सीरीज में। तो इनका जो आर कंबाइंड होगा वो आ जाएगा, आर कंबाइंड इज 20 + 28। 20 + 28 will be 48. So it's 48 ohms, and the current in the circuit will be I is equal to EMF over R combined. So that will become EMF is 12 volt and combined resistance is 48 ohms. So it will be 0.25. 12 over 48. It's 0.25 ampere. So the current in the circuit is 0.25 ampere. Now the next part is explain why Z experiences a force. In this part, they are asking the reason. Basically, a current will experience a force if it is not parallel or anti-parallel to the magnetic field. Current at any angle will experience a force. It will not experience a force only if it's parallel or anti-parallel to the magnetic field. Here we will say that YZ experiences a force. YZ has a current in a magnetic field that is not at 0 degrees or 180 degrees, because at 0 degrees and 180 degrees there is no force, but it is at, so YZ has a current in a magnetic field that is not at 0 degree or 180 degree, but it is at 90 degrees to the magnetic field. That's why it experiences a magnetic force. Now the next part is, tick the box which describes the direction of force on YZ. So which box represents the direction of force on YZ? For that, you see a magnetic field is from north to south and the current is from Z to Y. Because current is from positive to negative. This is the current. Since current always remains from positive to negative, so current is from Z to Y. This is the current. And the magnetic field will be from north to south. This will be the magnetic field. Now the force will be, if we use Fleming's left hand rule, so current is into the plane, magnetic field is towards right, so force will be vertically downwards. So this is the force. So this is the magnetic force. Force is vertically downwards. So we can say that, take the box which describes the direction of force on YZ towards N, towards S no, towards Y, towards Z no, downwards. In my opinion, the force is downwards because we have used Fleming's left hand rule. Now the next one. Explain how the direction of the force on YZ is determined. To determine the force, we have used Fleming's left hand rule. And in Fleming's left hand rule, we have cared about the direction of magnetic field and the direction of current. We observed direction of current and direction of magnetic field to apply Fleming's left hand rule. So we have observed the direction of current, direction of magnetic field, and then we applied Fleming's left hand rule. When switch S2 in the circuit is closed, calculate the total resistance of the circuit. So when we close S2 as well, other than S1, they said S2 is also closed, which means that S1 is already closed. So when both of them are closed, these two resistors are parallel. Let's call their resistance as Rx, for example. So 1 over Rx, because it's a parallel circuit. In parallel, we add reciprocals. So 1 over Rx will be 1 over 20 plus 1 over 30. It will be 60. 3 plus 2. So 5 over 60 is 1 over Rx. So Rx over 1 is 60 over 5. It's 12 ohms. So the combined, it's only for Rx part. Rx is 12 ohms. Rx is 12 ohms, and let's call this one R1, this one R2, and this one R3. R3 and Rx are now in series, so it will become R combined or R total is equal to Rx plus R Rx plus R3. Rx plus R3. Rx was calculated to be so Rx was calculated to be 12, 12 and 28. 12 plus 28, so it's 40 ohms in total. Now, question ka second part. Explain what happens to the force on YZ as the switch is closed. So when we close the switch, the overall resistance will decrease because we are getting another resistor in parallel. So as the switch is closed, we get a resistor in parallel, the combined resistance will decrease. A decrease of resistance will increase the current and hence the magnetic force. So they are asking that what happens to the force on YZ as switch S2 is closed. Closing S2 will lower the combined resistance as it will bring a resistor in parallel. When you apply a resistor in parallel, the resistance will decrease. So S2 will lower the combined resistance. So current and hence so current and hence magnetic force. So current and hence magnetic force both will increase. So current will increase and magnetic force will also increase. The next question is the current in the 20 ohm resistor is I20. The current in the 30 ohm resistor is I30. State the value of current I20 over I30. For that purpose, we will observe relation between 20 ohm and 30 ohm. They are in parallel. If the resistors are in parallel, their volts will be equal. So for example, if this is the resistor of 20 ohms, and this is resistor of 30 ohms, so the resistors are in parallel, their volts will be equal. So if 20 ohm has V volts, then 30 ohm also has V volts. However, current through 20 ohms is I20 and current through 30 ohms is I30. So I20 becomes V over 20. I30 becomes V over 30. Now we want ratio I20 over I30. So I20 over I30 will be equal to value of I20 is V over 20, that is to be divided by I30, that is V over 30. So V over 20 multiplied by 30 over V. So V cancel with V, and this will become 30 over 20. It's 1.5. So 1.5 is the answer. So I20 over I30 is 1.5.